Number 4 says graph segment RS from number 3, so we're using the same segment RS from number 3, and then perform a rotation first and then a reflection. So we're actually switching the composition around. So we'll rotate first and then reflect. And we're asked, does the order of the transformations matter? So we're going to see, does the order matter? If you want to take a guess, just tell yourself in your mind, take a guess. Does it matter or not? So first we need to graph RS. RS has endpoints of R is 1, -3. And S is 2, -6. R and S. Okay? So there's our pre-image segment. And then the instructions are to rotate first and then reflect. So I'm going to do the points again, because I think that will be easier. So R is at 1, -3, and S is at 2, -6. Okay? And so we're going to use our coordinate rules to rotate and then reflect the figure. Okay, so R prime, if we're rotating 90 degrees, okay, because we're flipping the transformations from number 3, if we're rotating 90 degrees, we keep our, or we flip our values, and we do the opposite sign for, opposite sign, so 3, 1. Opposite sign for that first value. So S prime would be 6, 2. So remember, when rotating 90 degrees, we flip them around, and then the first value becomes the opposite sign. So instead of -3, it's +3. Instead of -6, it's +6. And then we need to reflect it. So if we reflect it, that's R double prime. And we're reflecting in the y-axis. And when we reflect in the y-axis, we just change the sign of the x value. So this would be -3, +1. And S double prime, that's supposed to be an arrow there. S double prime would be -6, +2. So we've rotated it 90 degrees, and now we've reflected it across the y-axis. So let's look what that composition looks like, and see how it compares to what we have in number 3. So we have -3, +1, and we have -6, +2. Clean that up a little bit. -3, +1, -6, +2. So there's R double prime, and there's S double prime. Okay. So we've taken this original pre-image, we rotated it around, and then it got, or I guess we rotated up here, and then it got reflected over here. Okay. So how does that compare to what we had in number 3? Well, here was our pre-image, and then here was our final composition image. Here's the pre-image in 4. Here's the composition in 4. Okay? So obviously, these are not in the same place, so the order does matter. Okay? The order does matter. Yes, the order matters. Okay? Let's do this. Segment RS is in quadrant 2, not 4. So remember, our quadrants here goes 1, 2, 3, 4. So here, RS is in quadrant 2, but up here, RS is in quadrant 4. Okay? So obviously the order does matter in which you do these transformations. So you want to be careful with that when you're doing a composition, that you're doing it in the stated order. All right, let's look at one last example where we have a triangle and we're going to rotate it and translate it. Okay, so we do a composition of rotation and translation. So we have the triangle XYZ with the vertices x12, y35, and z63. So let's go ahead and graph that. We have x at 1, 2, y is at 3, 5, z is at 6, 3. X, Y, and Z. And so we're first going to rotate it 180 degrees counterclockwise about the origin. And so we're going to go this way. And again, we can use our coordinate rules to help us figure out what this rotation is going to be. And then we can kind of do the composition all at once because we can rotate and translate it using our rules. So we have X at 1, 2, Y at 3, 5, and Z at 6, 3. All right, so then we're going to rotate it 180 degrees counterclockwise about the origin. And if you don't remember the rule, which you're not expected to, we're just learning it now, so make sure you have those rules in front of you. When you rotate 180 degrees, the coordinate rule says I just change the signs of my x and y. Change the signs of my x and y. So you can see I had 1 and 2, but when I rotate 180 degrees, that's -1, -2. Same thing, 3, 5, rotate it, -3, -5. Okay, so that's the rule for rotating 180 degrees counterclockwise about the origin. Then I'm going to translate it. I'm going to translate x minus 2, y minus 1. Okay? And so this right here, my rule, is telling me how to translate each of these points. Okay? How to translate each of these points. So from each of the x values, I'm going to subtract 2, and from each of the y values, I'm going to subtract 1. So x double prime, -1 minus 2 is -3, -1 minus 2 is -2 minus 1 is -3. Y double prime, -3 minus 2 is -5, -5 minus 1 is -6. And then z double prime, -6 minus 2 is -8, -3 minus 1 is -4. Okay? So again, just using my rule here, subtracting 2 from each of the x's, and subtracting 1 from each of the y's. Okay? And that's how I get these points. So these are my rotated and then translated points. So that's the composition transformation. So let's graph those and see what that looks like. So I've got -3, -3, -5, -6. Erase this point. That's at -5, -6. It's right there. And z is at -8, -4. So we've got x double prime, y double prime. Oops, that's not y double prime. This is y double prime, and then z double prime. So this figure was rotated 180 degrees and then translated. Okay? Translated to the left and down. So what you can see that you really want to know is your coordinate rules. Your coordinate rules help a lot because you can do everything at once, right? So I start with my original point, and then I rotated it, and then I translated it, okay, using those rules. So you want to have those in front of you in your notes as you're going through these transformations. That makes it a little simpler. And then you can just plot your final points to find your composition figure.
In this unit, we have discussed three types of transformations: translations, reflections, and rotations. That's not all of the types of transformations, but that is what we'll cover in this unit. More than likely, you will want to go back to the other videos and notes to make sure you understand how to perform all of these transformations.